I already forgot which final exam it is. Let's pull up the title. The Fall 2017 final exam. So I figured I would take you through the answer key this time rather than just doing it all from scratch, because I already have it made, and it's just really calculator work. All right, that's really where people struggle with, not the act of writing stuff down. All right, so number one, and I already typed in the data for numbers 1 and 2. I'm going to try to save myself a little energy here also. All right, so for numbers 1 and 2, you're actually using the same function in the calculator. So stat edit to type your data in. Now I put question number 1 in L1, and then question 2 I put it in L2 and L3. So what I do in my calculator is going to be slightly different from what you do, or at least for number 2, but it's going to be the same general idea. So let me quit out of there. Stat, over to calc, 1 var stats. My data set is L1. Go to calculate. And we have the mean, the standard deviation, all that good stuff. Now, this is a list of heart rates and beats per minute, which is a sample of information. It's not a population. So we got to keep that in mind if a question asked us for something like the standard deviation. All right, because the standard deviation, it's going to be one of these two symbols, the SX or the sigma X, depending on whether it's a sample or a population. So something to keep in mind going forward. Anyway, that's not relevant to this problem. What we need is the 5-number summary. So I'm going to go down. I'm going to hit the down arrow until I get to the 5-number summary, which starts with the minimum, 58, Q1, 69.5, the median, 73, Q3, 75, and the max of 82. And what I do is I create a scale. You see my scale is separated by 5 units for each tick mark. I want it to start off with a value less than my minimum and end up with a value greater than my maximum. Could I have gone from 50 to 90 by 10s? Sure. Could I have gone from 0 to 100 by 25s? Sure. I chose to go from 55 to 85 by 5s. All right. And so that's how you create a box plot. You can verify it in your calculator, but at this point, I think it's just a matter of, let's just get the information and get it down on paper. All right. So number 2 is asking for the mean and standard deviation of each class. There's 2 ways to handle this, but if you want the information in one shot, I recommend stat calc two var stats, 2 variable statistics. The X list, L1, I tricked myself. L2, my Y list, L3. All right, and then I go to calculate. We could leave frequency list blank, or you could just put the number 1 in there. Oh, didn't miss that. All right, it may or may not work on your calculators. On these calculators, you got to do it separately. All right, so best laid plans of mice and men. We'll do 1 var stats on L2, calculate. So I'm going to hit the up arrow to get me to mean, which is 71.765. You got to be careful about rounding instructions. 3 significant digits, unless you're told otherwise in the problem. All right. S. Now I'm choosing S here, 13.62. Well, look at this. We found a typo here. Assuming I typed in everything correctly, there's no reason to think I didn't, because I got the mean right. So it's looking like we made a little typographical error here. So that would be 13.627. I did the whole spiel about rounding, and I think I know what I did here. For quality 7 is I just missed the 6 and I went right for the 8 and rounded that. What can you do? All right, so now I'm going to do the same thing, but this time I'm going to do it with L3. So stat calc 1 var stats L3, 63.5 and 20.222. It looks like I rounded that correctly. All right. Next up is figuring out what or whether the data sets contain any outliers or unusual values. All right, the first set of computations that I did was actually for for unusual values. So let me just do a little quick switcherooski here. Oh, I hit delete. Jeez, I am on fire. Fortunately, I mean, whoever invented the concept of undo is like a hero. Unless, of course, they did something terrible also, in which case they're not heroes. All right, so I think it's pretty obvious that the first one's addressing outliers. So the second one is unusual values. All right, so class 1 and class 2. All right, so the way I handle outliers is just determining whether the modified box plot is the same as the ordinary box plot. All right, so I go into my stat plot menu, and I just want to take a look at L2, because that's where my first data set is, and the modified box plot. All right, so then I'm going to take a look at the graph. Now, I got all this extra fluff going on here from another class. Let me just get rid of this. You just need to hit, once you select the function that you want, you just need to hit zoom 9, zoom stat. All right, this is what the ordinary box plot ought to look like. I don't have any loose disjointed points along the way, so I'm pretty satisfied that I'm dealing with a data set for class 1 that does not have any outliers. All right, so you're hitting second y equals, select plot 1, and then just toggle it to the appropriate plot. All right, my interface is obviously a little bit different. All right, so same idea for plot, my second plot for class 2. The ordinary box plot and the modified box plot are the same. All right, now when it comes to computing the unusual values or making a determination about unusual values, it really is just a matter of taking the mean that you came up with, and the rounded values are fine, 765, minus 2 times whatever you came up with for the standard deviation, 13.627. That'll give you a low bound, 44.511. Second enter recalls the previous computation. Slide in a plus sign there, and you get 99 point, well, mine's slightly different because I worked with the exact values, but it's going to be roughly 99 and change. All right, so then what you do is you go back to the original data set and see if any values in that original data set, which I guess I already had on the screen, class 1, are outside of that range. All right, so just at first glance, second glance, and third glance, I don't see any values that fall outside of the interval of about 44.5 to about 99. And so you just do the same thing with class 2, just 63.5 minus 2 times 20.222. That's your low bound. Then second enter, change your minus to a plus, delete, and second delete to insert a plus sign, except for whatever reason mine didn't take. There we go. Then enter, we get the upper bound. And there it is. All right. So any value that falls outside of that interval would be unusual. There are no values, it appears, that fall outside that unusual, that usual interval. So we're in good shape. All right. So that brings us to number 3. Just more data entry. You know, it just kind of is what it is. What I've kind of moved towards after a certain period of time, you know, your final exam, if you're listening to this video in the future, your final exam will most likely have 1 or 2 data sets tops that you need to type in, and it's just constantly referring back to those data sets. Here I just kind of went a little crazy, I don't know why. All right, so it's frustrating because it's like, oh, look at all the time and energy I spent typing this information in. So let me just clear it all out. So 1, 2, 3, 2 4s, then 4 5s. think I got what I needed. All right, 179, 196, 151, 178, 223, 260, 277, 279, 309. All right, so I'm going to take it on faith that I typed all that in correctly. All right, so you're going to go to Stat, Calc, option 4. It's going to ask you where you put your data. I put it in L1 and L2. All right. If a question involves making a prediction, you're going to want to store your regression equation. All right, to store your regression equation, you hit alpha followed by trace, and then option, wherever you want to store it, Y1 is the typical place. Alpha, trace, then Y1, and then go to calculate. All right, so you get a lot of information here, a lot of information that you don't really need, at least for this part of the problem. So there's a couple of different ways to represent. So what I wrote here isn't incorrect. It's just using StatCalc 8. So I'm just going to make a couple of notations here. So a little hat, first of all, because the proper notation involves a hat around above the Y. All right. So this is what you would get if you use the other way of finding a regression equation. So StatCalc 8. So StatCalc 4 gives you what we just came up with, which is the same information, just slightly organized differently. So Y hat would be 28.538 X plus 120 point, and that would round, if we're going to 3 significant, to 19. All right, so both answers are equivalent and both are full credit answers. So I'll put an or there. If it's a multiple choice question on the test, you just got to be able to recognize them both as being equivalent. All right. So now it says predict the score scored against if the number of losses equals 10. All right. So that we just do by selecting alpha trace. So this is alpha trace followed by Y1. So alpha trace Y1, then just type in parentheses the 10, and it'll spit out the value. Again, rounding brings it to 2 decimal places, but it's really 3 significant digits. All right. Number 4 is completely fact-based. That's the 4 conditions necessary to be a binomial distribution. It was on previous assessments, so that should be pretty straightforward. Number 5, a coin is tossed 5 times. Find the probability of getting at least 1 head. So that would be, so when you're talking about at least 1, it's 1 minus the probability of not getting any. So the probability of getting no heads, and I'll just annotate this a little bit, would be the same as 1 minus the probability of getting a tail and a tail and a tail, 3 tails, 4 tails, 5 tails. All right. And since the probability of getting a tails in a fair coin is 1 out of 2, and means multiplication, this would be 1 out of 2 to the 5th power. All right. And the rest is calculator work. Number 6, a die is rolled and a geometric figure is selected from the sample space. What is the probability of not rolling a 3? All right. So we roll a 6-sided number cube. 3. The outcome of a 3 is 1 outcome out of 6 available. We don't want that 1 outcome, which means we want the other 5. And the probability of not selecting a triangle, so we want everything else except for the triangles. All right, so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we want these 2 things to happen one after the other. So we multiply. That's the multiplication rule. And any of these 3 variations of the answer, 50 over 72, 25 over 36, or 0.694, because that 0.694 is rounded correctly, they all would be acceptable for full credit. All right. Number of arrangements of the letters in the word Plato. Right? I use the permutation notation here, but you don't really need that, because if I have 5 letters to work with, that means that any of the 5 letters could occupy the first position in my new rearrangement, P, L, A, T, or O. After I use one of the letters, there's only 4 letters available. I don't know why that happens. I just go boop, boop. Once I use the second letter, then only 3 are available, then only 2, then only 1. In which case, through direct multiplication, you get 120. All right. Contingency table. Probability. Look at this. I mean, this is just a mess. I mean, what I did was I copied and pasted from a previous assessment, but I guess I didn't change enough. Given the following contingency table, let's get rid of this. And then 1 individuals is selected at random. Oh, geez, Louise, this is brutal. 1 individual is selected at random, find each. Probability of a cocaine user given that the individual is in the 26 or older range. All right, so that's why I highlighted that particular interval. All right, so that's this group here. All right, so the given tells you where you're focusing. All right, so it's telling me that I'm only looking at the 26 or older group. All right, from that group, I'm looking at the cross-section involving cocaine users. There's 1,006 individuals in that group, and there's 2,583 in the 26 or older group. All right. Probability of being a marijuana user, just in general, that's a little easier, because all we're doing is we're taking the total number of individuals who use marijuana and taking that value, dividing it by the total number of individuals in the study. All right. So then the next part is 2 individuals are selected at random without replacement, find each. So we're just kind of building off of the previous answers. All right. So if I know that the probability that like cocaine user given the 26 or older age group is 1,006 out of 2,583, and if I wanted to select the second one at random, there's 1 less individual in that group of the cocaine users that are 25 or older, and then there's 1 less in the 26 or older, and there's 1 less in the 26 or older group overall. All right, so you multiply those together, and you have it. Same idea for the marijuana. Reduce by 1 top and bottom, multiply across, call it a day. All right. Number 9 and number 10, and forget the bonus. Number 9 and number 10 are very straightforward, I think, because they're procedural. In 1975, a random sample of 1,484 adult U.S. citizens was surveyed, and 193 strongly agreed with the statement people should take care of themselves. Then in 1991, really, I'll throw in the words here just to kind of emphasize it, a second group of individuals, we have 1,013 adult U.S. citizens showed that only 61 agreed with the statement. Does this indicate that the proportion of U.S. adults has dropped? All right, so because we have 2 proportions from separate groups, that's telling us that we're dealing with a 2-prop z-test. All right, so this is a 2-prop z-test. All right, we typically write, I did this for this one semester, we typically write the null before the alternative. Yeah, good enough, close enough. All right, the dropping part would mean that the proportion before is more than the proportion after. But then when we put this information in our calculator, we get a very small p-value. Because there's a teensy tiny p-value, that tells us that we are okay to reject the null and therefore go with the alternative. All right. So sufficient evidence to reject the claim that the population proportions between the 2 years are equal. All right, that's what the null hypothesis was talking about. at the 0.05 significance level. Therefore, the claim that the proportion has dropped would be true. All right. And number 10, a question related to design of a study. And so this one, it really just, I mean, the answers vary, so I kept my response pretty vague, I guess. Sample bias due to the fact that only Gerber customers were polled. You know, because you would think about it, and it's like Gerber wants to compare their best sweet potato baby food to beech nut, right? So, but they only polled their customers, their former customers. How do we know that their former customers even have a basis of comparison? Right? So, you know, so they send them both Gerber and beech nut brand sweet potato baby food and give them a rating scale on how their child responded to each brand. You know, like I was thinking of it this way: it's like if I gave my kid at the age of whatever the age, you know, like 6 months, 8 months, you know, something that they're completely unfamiliar with, and in place of something that they actually liked or are just familiar with, the first thing that's going to happen is that's coming right back out, right? So just the familiarity itself might be enough to get the kid to make you think that he or she prefers the Gerber brand when really the beech nut would have been perfectly fine, except they were used to the Gerber brand. So that's just one example, but the idea is that there's bias in here. And so any kind of explanation that you provide that involves a